Hi everybody. In this video I'm going to go through Lab 5, which is about files. So in this assignment you're going to be using this earthquakes.csv input file and implementing 3 different functions, and you'll want to match the sample output perfectly. And so let's start off by downloading this earthquakes.csv file. And we want to put this in the same directory that we're going to have our Python file in. So I'll save that in my CSCI 127 Summer 2020 folder. And then I'm also going to download the Lab 5 file. I would save it as my first name, last name, Lab 5, and it will be a .py file, and it's got to be in that same folder. So I'll save that. And then to start off, I'm just going to go ahead and take a look at this earthquakes.csv file. If I open it with, say, something like TextEdit, just a really basic text editor, I'll see, this is very small, let's see if I can make it bigger. I see that this file has in each line just comma separated values, so and it looks like there's information about day, depth, distance, etc. This is information about earthquakes, and each line is a different earthquake. So it looks like the first day here is 27, the depth is 15.12, and if I have a program like Excel on my computer, I can open this with Excel to take maybe an easier look at it. I'll make this bigger for you, maybe, yes, just a little bigger. Okay, so yeah, so here we just have a nicer view. Excel's interpreting that input file for us, and so we can see there's a variety of depths, distances, and each one of these lines is one earthquake. We can see this first earthquake looks like it happened in California, magnitude 1.43, etc. So now let's take a look at that Lab 5 file. So I'm going to open my Lab 5 file right here. Okay. And it looks like I'm going to fill in those missing functions that I said I needed. So if we look back at the description, we need to implement average magnitude, earthquake locations, and count earthquakes. So let's just take a look at average magnitude. It's supposed to calculate and return the average magnitude of the recorded earthquakes. So I'm going to need average magnitude, and I can see down here that average magnitude is supposed to take in a file name. I'll just call that F. And what is this supposed to do? Calculate and return the average magnitude of the recorded earthquakes. I'll even just say that verbatim. Calculate and return the average magnitude of the recorded earthquakes. And I know this needs to return something, and so even though the average magnitude in the end should not be 0 probably, for now, will just return 0 and call that good. I also need to implement the earthquake locations function. So definition of a function, earthquake locations, And let's see when that gets called. It gets called right here, and it looks like it's not, I'm not using any return here, so it probably doesn't return anything. Earthquake locations also takes in a file name, and what does this need to do? It needs to identify every unique location and print them in alphabetical order. Am I not? Yeah. I scrolled over a little bit here. Okay. Okay, so this function needs to identify every unique location and print them in alphabetical order. And I do not need to return anything, so I'll just pass here because I need at least one Python statement in my function. Now I also need a count earthquakes function. Count earthquakes. And it looks like this count earthquakes function should return something. And the parameters that the count earthquakes function takes in are the file name, call that f, a lower bound, and an upper bound. And this is supposed to return, actually, let's take a look down here. This function should calculate the number of recorded earthquakes that have a magnitude greater than or equal to the lower bound and less than or equal to the high bound. Okay. I'm going to put that in as a comment. Okay. And scroll back over. So this needs to calculate the number of recorded earthquakes basically between the lower bound and the upper bound. And again, just for now, I'll return 0. And let's take a look and see if this runs. And so it looks like I'm being prompted for an input, and let's take a look about where that happens. Yep, that makes sense. That's where we get our lower bound and our upper bound. Maybe say my lower bound was 2 and my upper bound was 4. And then we already have this printing functionality that says the number of recorded earthquakes between the lower bound and the upper bound is 0. And why is it 0? Well, because the way that this code is written right now, it should print in that third space the how many variable. And what is the how many variable? Well, it's just whatever we returned from count earthquakes, right? Count earthquakes, and we're just returning 0 every time. And so it's going to be our job when we do this lab to fill in all of these. And so just to start us off, what I'm going to do is I'm going to actually implement a function that is not part of the lab, just as an example. And I'll call this max depth. And this will take in the file name. And what is max depth going to do? It's going to, let's say, return the maximum depth of any earthquake in the file. So this is not part of the lab. This is just how I'm going to give you just a little demo of what it looks like to work on this lab. And let's, for now, just like we've done in our other functions, let's return 0. And maybe let's actually comment out, I think I can, oh yeah, comment out region. I'm going to comment out everything here. I'm just going to call my depth equals max depth of the file name, and I'm going to print max depth is, and then I'll print that depth. So right now, what do I expect my Python program to do? Well, it should just print out 0, the max depth is 0. So let's try that. And yep, looks like we're doing that correctly. All right. So what do we need to do here? We need to figure out what the maximum depth of any earthquake is. So a good first step here is to read in the file, right? How do we do that? We say something like file object is assigned to be whatever comes back from opening this file, right? So now if we do this, file object will be assigned to whatever comes back from opening the file. And to start off, let's just go ahead and take a look at whatever the first line of that file object is. So we're going to print file object dot readline and see what that is. And as we would expect if we remember what that file looks like, the first line is that header line, right? It tells us what all the headers are. Day, depth, distance. If I still have that open, we'll see, yep, day, depth, distance, etc. But if we looked at another line, say, we'll see that the next line has that data about the first earthquake. And so when I'm working on parsing a file, which is a very common task when you're programming, especially when you're trying to deal with data, I usually try to look at just one line and see if I can kind of accomplish the task that I want to accomplish with just that one line before moving on to iterating through all the data. And so what would that look like in this case? Well, I would make a variable called something like first line. Maybe I'll call it first quake, because this is actually our the first earthquake, and this is the header, right? So the very first line of the file is that header information, and then the second line is the first earthquake. And so we saw that all of these values are just separated by commas. So a very useful string method is a split method. And so if I say something like the data for that first quake is first quake dot split, and if I just pass in nothing to the split method, it will split on white space. But if I pass in some string, it will split on that string. And so, oops, let's go back to the shell just to try this out. So let's say example string here. If I say example string here dot split, and I split it on a comma, what I'm going to get back is a list of strings where each string is part of my original string just split up by the commas. And so for our data, like if we want to separate this into a list, we can use the split function with the comma. So that's what we have here. And maybe let's just print this and see what it looks like to just confirm that we're getting what we want. All right, and it looks like we are. And so we want to look at the depth, right? And it looks like the depth is the second column here. And so, for example, 15.12 is the depth of the first quake here. And so if I want the depth, what is it? It's just data at the index 1 position. So that's going to give me whatever was in this second slot of my list. And I probably want to remember that this is a list of strings. And so if I want to use this as a float, which I probably do because I'm going to be wanting to compare it to other depths to find the max depth, then I'm going to need to cast it to a float, right? So now, if I do something like print depth, well, I should see 15.12, right? And let's just double check that. And indeed I do. So it looks like I now know how to get the depth for one line. And so at this point, what do I need to do? Well, instead of just doing this for one line, I need to do it for every line after the header. How do I do that? Well, I can do something like for maybe line in file object, which we'll note that since we called readLine on file object, we're now pointing to the second line in the file. And so we will go straight to that first quake. And what is, maybe actually I'll say quake, for quake in file object, because that's going to give me that line. And so quake is actually now, I already have quake. We can confirm that though. Maybe we're going to want these in our for loop. So maybe I do something like print, print quake, because I just want to show you that that's going to be those lines of the file. But if I run this, ooh, first quake is not defined. Okay, so this is actually going to be quake now. So I think this is going to run and take a long time, but I think I can press Control-C and stop it. Yes. So it looks like we are indeed getting lines of the file as the variable quake, just like we want. And so now I'm just going to delete that. And so now we should be getting depth for each line of the file. But our goal is not just to, say, print out the depth for each line, it's actually to figure out the maximum depth, right? And so what do I need to do? I need to create a variable that I'm going to check every time I go through my for loop. I'm going to see, is the depth in this line for this quake greater than the depth, my max depth that I've seen so far. So create max depth variable. And then what do I want to do? I want to check whether depth is greater than max depth. How do I do that? I say if depth is greater than max depth, then what should I do? Set max depth to depth, right? So now my current max depth is like this depth that I'm seeing right now is the biggest, and so I should record that. I'm going to say max depth equals depth. And at this point, I believe we should be good. And so we're going to need to return max depth and see what happens. And we get 622. That seems like a very deep earthquake, so I'm willing to believe that we have correctly implemented this max depth function. And so just a reminder, this is not something that you're required to do. This was just an exercise that I was using to show you how to work on this lab. So good luck with the lab, and please ask if you have any questions.